TOMz. TOMz, and welcome to another match show of only the best entertainment apha emzansi. Mna ke ndingibongisipho.
Hola bongi, hola nani lapha emakhaya ngiyathemba ukuthi niyilungele namhlanje ke endleni nathi khona la ku SABC 1 emzansi for sure igama ku siyabonga wakwala proudly brought to you by the SABC Education. Bongi namhlanje sibaphathileni.
Well, when I say we've got a jam-packed show namhlanje, we'll be looking at all the materials esisebenzayo ukuze sakhe izinto. Things like buildings, inqwelo mafutha, or rather inqwelo moya, imoto, and these are all the things that are constructed out of these specific materials, and we'll be uncovering some of those materials right here, right now.
Ngempela sikhuluma nge-mass, density, hardness, stiffness, flexibility, and natural processes like corrosion are all things ekumele ucabange uma wakha noma yini.
Injalo kanye ke wena siya, and the strength of the materials you use has to be suitable for umsebenzi lo. Wena ke apho ekhaya hlala uhleli, because all you need to know about this and more is coming up.
Let's get it.
Coming up next on Teenagers on a Mission, we find out about some of the worst failures in the construction industry. Sifunda about all the materials ezisetshenziswa to build inqwelo moya. Singena inside the legendary Roy Falk helicopter, and in Clockwise sifunda all about the history of concrete. Buildings and constructions are part of our everyday lives. Sisebenza kuzo, siya esikolweni kuzo, but there's so much that actually goes into ukuzidibanisa.
Have you ever thought about how many bricks were used to build your house, or how the materials are used, or rather able to stand up? Engineers, architects, futhi nabantu abakhaya use their expert knowledge to figure all of that out.
Injalo kanye sesahamba ke njengesiqhelo sayibuza lo nalo wabo bacinga ntoni, masike siyibona uba iitshomi zethu zapha esitratweni zithini.
Kufera Mukran.
Ngiyaphila futhi ngezwa konke.
Ngimnandi ngicela igama.
Igama nguSenzo kwaMajoli School.
Okay, Senzo mina ngifuna ukwazi niyabo ucabanga indlu yala emzansi nje average house yenze ngetini ezingaki?
Close to 300,000 lapho.
Let me say 100,000.
Okay.
Yeah. Boma 3,000 something. Ngoba mina ngihlala ku big house out here.
Plus mana kahluka ngetina ikhona lezi zakudala inkundla lezi ezincane.
Yes.
The first brick ngasho boma 3,000 something.
Okay. If when you would live in a house nje la emzansi, what kind of a house would you live in?
I think my house would be situated in a location.
Okay.
And then it would be a double story or something.
Hlala ku.
Vale mangayihlala kuma mansion house kanje.
Yo mfethu bengifuna ukuhlala kuma Richway yazibona lezo indawo lezo. Nami mfethu ngifane nabo Kaizer out yami ngoba ngifela because out yami. Fane no Kaizer nami mfethu ngene la mfethu uplomela esingamlini.
Ngifuna kuma big house mfethu nabo maphulinyana nje yabo. Angizokwazi ukuthi ngidiphe nje.
In case you're wondering, there's actually an easy way you can calculate the number of bricks if you just know the measurements.
Ngempela, too clever now boom. Lokhu kwaze kanjani ngempela?
Well, when I see a nani apha emakhaya, you take the height of the wall in meters, multiplied by the length of the wall in meters, then you multiply that number by 120, then ufana ibendlo yakho.
So easy, very easy man lento. Well, that's something that ochwepheshe bethu lapha kwi-construction kumele bayenze njalo nje. Kodwa ke uyazi ukuthi building doesn't always go so smoothly. There have been some major problems throughout history yethu ngokwakha, and it's mostly done by abantu laba bakhayo. Hayi, asesiboneleni.
In 1986, the Lee and Yak building in Singapore, a 6-story building which had a hotel, a bank, and a nightclub in it, crumbled to the ground in less than a minute. 50 people were trapped beneath the rubble, and 33 of those people were killed. It turned out that the building's original engineer had made a mistake. He had miscalculated the weight of the building, and the building could not support its own weight. 20 years later, during an international fair in 2006, the roof of Katowice Trade Hall collapsed on 700 people, killing 65 and injuring 170. Now, all of this happened because the building's management didn't remove a build-up of snow. So then, snow buckled the roof and it was never repaired. So we need to make sure that we build the right material in the right way. Siyacela guys. Yo, that is some pretty hectic stuff, eh? If you aren't building using the right materials and proper engineering.
For sure, I mean, many factors like the environment, ugrasta, moya, kanye futhi nemvula, they can all affect what you build. Scarce I couldn't get about some very specific materials that are used in building amapano. Yazutin, Begala.
Okay, my name is Sid Singh. I work for Denel Aviation as an engineer. I studied aeronautical engineering at the University of the Witwatersrand. Specifically, I'm a reliability engineer. So we measure the performance of the aircrafts, the Royfalk as an example. Like I said, measure performance of different systems. Obviously, things don't always go according to plan. You have components that fail, systems that fail. So we analyze those failures, try to find out what happened, what went wrong, and try to come to some conclusion and propose corrective actions for that. Either a redesign of the component in order to improve the reliability of the aircraft. The study of aerodynamics deals with the flow of air, because air is basically a fluid. It's very much like water, and we deal with the movements of air over surfaces and over objects. So we're basically treating this aircraft as an object that is moving through a liquid, but in this case not liquid, it's air. Now it's very important that you don't have surfaces which have large surface areas which creates a lot of resistance. You want it to be as streamlined as possible. So that's why you have the shape of the wing, for example, is like a teardrop shape, so that the air particles can move around it without too much interference. You don't, for example, want a flat face, because then the air has to move a hell of a lot to get around it. So those are some of the things you take into consideration. Obviously, the strength of the material you're using is very important as well. Aluminium has a certain strength. Steel, like I said, is stronger, but it's a lot heavier as well. So the strength of the material, the shape of it is very important in your aerodynamic design. A lot of different materials are used, but most of the aircraft, the actual frame and the wings, is made from aluminium. Aluminium is a very good material because of the properties. The two main properties are its strength and its weight. With an aircraft, you want the material to be light because you want the aircraft to be able to take off, but you also want it to be strong. You don't want things falling apart. In the past, they used to use wood, which was relatively light, but it wasn't as strong, obviously. Aluminium is not as strong as steel, for example, but it's a lot lighter. So aluminium is an ideal material for most aircraft components. Obviously, as you fly, you go up into the atmosphere. The higher up you go, the thinner the air becomes, and that's basically the pressure which you're experiencing as you go up. In science fiction movies, you probably see astronauts or whatever in space. If they take their spacesuit off, they kind of explode. That's because there is no air, there's no material, no air particles in space, and basically that's what happens the higher up you go. So us as humans, we're used to this environment on the ground. Now we need to maintain this atmosphere up in the air. So what we do is we pressurize the cabin. In other words, we don't allow any air in or out into the cabin or the cockpit in order to deal with that. Obviously, the aircraft structure, the frame needs to be able to deal with those forces. So the aluminium frame needs to be strong enough to deal with that, because you have a difference in pressure. You have more air particles in the cabin and a lot less outside. So there's going to be that pressure differential, which is a major force acting on the structure. In order to deal with that, you need a strong structure. Different materials will react differently to different environmental conditions. You need to, yes, very important, need to take into account expansion and contraction of these things. Typically, it's very cold up there, and materials will contract. In university, you have a whole subject on materials which deals with expansion, contraction. How much you can calculate how much a material will expand or contract by, depending on the temperature. Based on those calculations, you can do your design. It's all, yeah. So all these things are measurable. Nothing is left to chance. The glass used in the cockpit is quite different to the glass you might see at home in windows and that kind of thing. This has to be able to withstand extreme forces of pressure as well as slight movement. At home, your windows don't really bend, that kind of thing. But here you will get a bit of bending as you experience pressure forces from flying through the air and that kind of thing. So it has to be quite strong, and the reason it's curved is to minimize reflections from the sun. That's for tactical reasons, so that it's not as easily spotted by enemies and that kind of thing.
Njengoba ke kulula ukungena kwinqwelomoya ubhabhe siyazi ngoku how much science actually goes on behind the scenes.
Every time a plane is built, the people behind building it are taking passengers' lives into their hands. So they have to know lento le abayenzayo. Sathi shelele kancane idolota ke bese sibuya thola kabanzi about the construction of another flying machine, the Roy Falk helicopter that was designed right here in Mzansi. Azokuthini?
TOMz. TOMz. Teenagers on a mission right here on SABC 1, Zanzi for sure.
Safuna abanzi about all the important properties of materials used in construction la namhlanje. And so far, sasibona ukuthi yingahle kahle eya building a plane and also some epic construction fails.
That was quite scary, hey? Now if you don't build properly, people can get seriously hurt. So keep tweeting us and look us up on Facebook. And don't miss our social segment coming up later, and we'll catch up with you.
Sasibone ngempela ukuthi amabhono iwona akhiwa kanjani. So thina sacabanga ukuthi azothini ahlalele emoyeni ngoba sikhulu nje kanjalo. Kodwa ke next up we'll check out an amazing flying machine that was created right here in Mzansi.
The Roy Falk helicopter was designed to withstand the harsh African environment and can operate for extended periods without major support.
I'm an aircraft mechanic, more hang 5 more in airport. I'm starting to become an aircraft mechanic. Roy Falk red Kerstel. Yeah, in English is red Kerstel. It's a helicopter, army helicopter, designed and manufactured in South Africa. It was designed actually to help peacekeeping in Africa, especially with the border post and also around Africa with the Cold War back in the day. Roy Falk is a very big aircraft. Not big as per se big, but it's big compared to all the other helicopters. So also it constructed for withstand the opposition so like Kale, now we're excited landmine hanch to attack about. So we don't got landmine the bomb zone it gas affect the aircraft. Diamco you're strong at it. Very low river strong to stand on to Momo Africa. Roy Falk it's a rotating aircraft. The rotors are one like it's a hollow like 15.8 meters, yeah, somewhere there. So those rotating they become low pressure system. Only gear shaft is connected to the gearbox that day. So here aircraft is like the spinner, the rotary wing, the bleeds the spinner. It causes low pressure. So in the cause low pressure, the rotary wing can cause aircraft to lift. Because this type of aircraft, the wings are used for the lift. So when the more rotary wing aircraft, the wings it causes low pressure modi, but they can't pull aircraft to body. That's why aircraft can't go more in a good deal. Shape ya Roy Falk, it's only the aircraft, the helicopter range. My problem is that motomo pilot Yamatom in Nagopele and when Namudi Mount. So when a shape as if Ungari in Nassau or Agizuru or Gusagrada. Like Komorao, wing a thingy, le tail, Keholo compared to Gopel, because Gopel again transave compact to Pasapala Tata during impact. So when the pilot or co-pilot in Namopel and then Engwell Nagudi, because one quadi Gani and the Nomo can steering aircraft hanch. Roy Falk hanch main body yating, but very aluminium. Ne? Because of aluminium thing is light, come connected with and flexible, and also every bital corrosion. And then in terms of the fuel tanks are on Roy Falk, Kevlar. Kevlar is bulletproof and a light, very strong. So when especially when Roy Falk war chopper, go into it. Now we the bullet hanchi shoot down aircraft again. So when die then hanchi have a better aircraft, papunya fuel tank. Your catcher spark, because vapor fuel, a catcher spark because of oxygen. Sharp. And then we know mabili hanchi ba say alloy more willing or anne stronger and lighter at the same time. Hanchi lidi fast nazar na tse ba di bikisa mo rofa ka ke di fast nazar di reng hore ari heavy and hape di khona withstand the pressure tse di khangele go di.
The Rooivalk is a mean machine with a range of weapons as does the Chincheke depending on what mission it is on. It's got a 20mm cannon in its nose and can also carry missiles, anti-armor missiles, and rockets. Now that's a lot of weapons. It's also got a fire control system to find its targets and an advanced navigation system that uses radar and GPS. I-cockpit ke yona ihlalisa abantu ababini, and when the Rooivalk first came out, it was the only helicopter apha emhlabeni that could do a backflip. How cool is that? Wow, now that is a pretty amazing machine. And Zimbabwe, it was all built for our conditions and the environment yet.
Abanga just uvela with one of those flying machines called a live studio said to yo, parking might be a bit of a problem.
Yeah, no, yes, but certain producers out there about building a landing pad here somewhere. But because here's what's coming up.
We go back in time in Clockwise with Tolega Bands about all the history of one of the most popular construction materials, concrete. Futhi sibheka one of the most amazing apps lapha ku cyberspace. Futhi sola some life-changing career advice kongqwapheshe bethu.
TOMz, SABC for sure. Proudly brought to you SABC Education.
Says for okuningi about the science behind work izinto namhlanje. Kodwa ke asikaqedi ngoba kusekuningi empela okuza kuningi.
Injalo kanye ke wena siya because apha ke TOMz we never disappoint viewers because we heart them, we love them, sibathanda too much. So ke wena ke Africa, get ready for a trip back in time, social media and cyberspace 3 in 1, 1 in 3. What?
Kusazoba mnandi.
Now, yonke building what we it has been engineered to support the weight of the building itself, furniture, and all the people abangena kuyo.
Now, wonke ke lama material asetshenziswa ukuthi akhe lama structure lawo has been engineered by great minds over the centuries. Okwamanje ke asitholeni kabanzi with a trip back in time in Clockwise.
Ngamaxesha akudala ke iclay yayisetyenziswa to bond substances together before the invention of cement, and it was only in 1756 that British engineer John Smithson made the first modern concrete or hydraulic cement by adding pebbles and mixing powdered brick into his concoction. In 1824, English inventor Joseph Aspdin invented Portland cement, which is still the most widely used cement in concrete namhlanje. Aspdin created the first true artificial cement by burning ground limestone and clay together. Now, the burning process changed the chemical properties of the materials and made much stronger cement. The other major part of concrete besides the cement is the aggregate. Aggregates included sand, crushed stone, gravel, slag, ashes, burnt shale, and burnt clay. So, concrete is one of the strongest building materials out there today. I mean, it's pretty much unbreakable and can withstand bad weather and much more. Most of
the buildings are made or reinforced with concrete. Any bridge you come across or any mall you go into or any office or are all built with concrete.
It's like go-to material for everything. And then you think about what materials we'll be using up in the future.
Space concrete maybe, rocks from Mars maybe. Here's a little taste of the future in cyberspace. Let's go!
If one of you are impressed by the Rooivalk helicopter early on, then check out the Denel AH2 Rooivalk wallpaper for my Android. It is a collection of pictures of the Rooivalk that you can install on your desktop, and it allows you to set in picture wako utazichinja automatically njalo njalo. If one of you play the helicopter yako, then you gotta check out the Chopper Combat Simulator app. The Air Combat Sim lets you fly an Apache Strike helicopter and battle naval warships. If one of you about structural engineering, download the Engineering Libraries app. The app has a quick reference guide for civil and structural engineering students. It bundles needed to know information on wood, concrete, and soil through the simple interface. How about that? Download it now.
So namhlanje about building and engineering. You want to get into a career in building and designing buildings?
You can take your pick of jobs, and drawing is an amazing career that lets you both be creative and very, very technical. Craftsmen.
Draftsmen and women, or drafters, translate the ideas and rough sketches of engineers, architects, and scientists into detailed drawings. Now, the drafters normally specialize in preparing drawings in various fields as aeronautics, architecture, civil engineering, and electrical engineering. Now, in most of these fields, girls are one by you'll use a software called CAD or AutoCAD, which will give you the edge in a fast-moving high-tech industry. Now, CAD, you have a very good start in creating working drawings that can be used in many different areas. Why again will have a good idea of what you'd like to specialize in. Google short courses in CAD to find out how you can start learning the skills you need to be a draftsman. So go and keep being creative. And who knows, you could be designing the buildings of Igamalid.
We spoke to the special guests on today's show, and how they get into it.
So if you are interested in a career in engineering and you typically enjoy subjects like maths and science at school, you will probably enjoy engineering as a career. You'll need to study at a university. It's a 4-year degree to do any form of engineering, aeronautical, mechanical, electrical. And for me, engineering is not so much about learning how to solve a specific problem. It's more about a way of thinking and how to approach any kind of problem so that you can apply what you know to any situation.
Only different type of aircraft mechanics. Only it's avionic, only it's electrician, only it's F-frame. So when I decide to work F-frame and giving you kaka, come calculating mechanics because na can go to one pilot aircraft to this ama pillar, then this ama second na. Who feel more to qualify? We close study salary now for 1.5 year, 1 year, depending on when I for your apprenticeship. You're on a basic thing arena, and then once you go OGT on job training. We train now for 1.5 year.
Kufikela xesha ke silithanda sonke so much apha enkqubeni xesha loba nina nithetha nathi sithethe nani sithethisane email angqobo siyasiphethe bani PS thini
namhlanje ke siphethe uhloni hloza lapha on Facebook athena thank you so much TOMz for inspiring me to become a scientist.
Yes, going to see with the whole scientist thing. Don't abantu abaninzi are actually intimidated by maths and science, especially in our school.
I think as I want to have to shy away from the perception of what science is actually difficult. I mean, it's actually doable.
And yes, sisebenza for ukwenza yonke into like buying groceries sithanda ukutya.
And of course, it's TOMz Lana has your back, so you have no need with usabe lapha ekhaya because it's better every day, all day. Science and technology is what we do best.
So ke uba umuntu mhlawumbe ufuna ufana nohlonza wenza njani si?
You can simply go into our Facebook and Twitter pages. Scroll down on facebook.com/TOMz at TOMZ_SABC1. Kwazi ba nawe ngayithola usulana ohlelweni lethu nje sifunda your comments on our screen. Till next time, keep tweeting.
Wow, wena siya ibisixaka mlomo seshow esisanamhlanje.
Jam-packed show for sure. Sifunde kabanzi ke about what it takes to build everything. Kusukela amabhanoyi kuma helicopters and major buildings. As uthini Mzansi, it's been epic.
So much so, but ke ngelishwa all good things must come to an end. So we have to say goodbye for ngoku. But until next time, midnight sanibona. TOMz too.
Goodbye.
Coming up next on TOMz, discover the science behind everyday things when we learn about forces. Go pro with kickboxers to find out more about their strategies. Explore the crazy cool interactions between magnets and umbane. And get your adrenaline rush when we learn about science behind skydiving. Ungaphoswa ke ngu-TOMz qho ngemivulo nangolwezibini ngentsimbi yesine apha ku-SABC1 Mzansi for sure.